Hello, my name is Manuel, and together with my colleagues from RICO, Northern Sound Health Corporation, and Alaska Native Medical Center, I'm here to present a study on 3D imaging of ear infection in Alaska Native population. Now, ear infection affect 93% of children by the age of 7. There are different types of ear infection, but the most common one is acute otitis media, which is also the most common reason for antibiotic prescription to children in the United States. Although it's a very common infection, it's still often misdiagnosed. And when I say very often, to give you some number, like pediatrician, they have an accuracy of 65%. So this leads to the fact that there is an overprescription of antibiotics to children, and therefore this is contributing to the worsening problem of antimicrobial resistance. Now, the main reason for this comes to the fact that the doctor usually doesn't have enough time to look into the ear of a child, especially because of cry, or make sure the child moves. And also the fact that for the perception, so the doctor can see the eardrum only through a very tiny lens, or maybe through a 2D image. Now, the 2D image limits the ability to extract feature-based shape-related feature, which characterize each of these diseases. Our goal is to find a way, basically, to bring the accuracy of a specialist into the hand of a pediatrician. Now, to do this, we use a learning-based approach, or we investigate a learning-based approach. But first, we want to say, well, let's wait. First, we should probably give a tool that is capable of extracting more information, so the learning will be easier. Okay. Now, our approach is first, we need to identify the place with a large variety, let's say, of ear disease, and then we have to design that tool. And then, so that place was found in Alaska, because we found the Alaska Native population has a lot of ear infections. And the tool we use is a light field otoscope, which is designed by RICO, and is a camera capable of having the 2D image and the 3D also reconstruction from a single shot. Now, to give you some example, we have what this device can produce. We have the 2D image in the first column, then we have the 3D reconstruction, and some additional feature, which is a contour plot. Okay, so where every color has the same depth. Now, as you can see, although the image doesn't look, looks approximately similar, you can see the top, for example, there is a big perforation that was not visible from the 2D image. Now, again, if you check the 3D reconstruction, you can still see, for example, the difference between acute otitis media and other type of otitis media. And here it's very clear. The first row, you can see there is a kind of donut shape, and that is very characteristic, and that is not very visible from the 2D image. Now, this allows us to extract some features, so based on both the color and the shape, and then implement this feature and give this feature to a learning-based approach. In this case, we use some classifier based on a neural network. Now, the main question is, can we achieve an automated diagnosis? Well, we found that it's not that easy. It's a bit challenging, because the doctors don't want to go from basically deciding to not deciding, right? So we designed two paths. So we have the first step is at the top, where we classify some, for example, some feature which, for example, is bulging, and then the doctor will take the final decision. So we're just helping, assisting the doctor. And the second case, where we actually classify the different types. And here I give you some preliminary results on the worst case, average, and best case for each of those two. And if you want to come to our poster, please, we also have a demo, so we can image your eardrum or show some examples. Thank you.